4.1.3, graphing the sine and cosine function. Recall that we learned the unit circle, and so we did graph these last year, so this should be reviewed, but remember that we can graph using radians and degrees. So of course this year we're going to always use our radian measures, and this is part of our unit circle that I have in this table right here. So we know if we're thinking about y equals the sine of theta, so theta would be your x values, and then your y values would be the sine of whatever it is that you're taking. So the sine of 0 we know is 0, the sine of pi over 6 is 1/2, the sine of pi over 4 is root 2 over 2, pi over 3 is root 3 over 2, the sine of pi over 2 is 1, and so on. And of course right here we have all the decimal values for each of those functions. So if we go ahead and just recall our graph from last year for the sine of x, remember the graph is smooth and rounded. So let's go ahead and start off. Remember that we're going to use radian measures always for our x-axis. So we know that the sine of 0 is 0. The sine of pi over 6 is equal to 1/2. The sine of pi over 4 is root 2 over 2. The sine of pi over 3 is root 3 over 2. The sine of pi over 2 is 1. 2 pi over 3 would be root 3 over 2, root 2 over 2, 1/2. At sine of pi is 0. At 7 pi over 6 we have negative 1/2. Negative root 2 over 2, negative root 3 over 2, negative 1, negative root 3 over 2, negative root 2 over 2, negative 1/2, and back to 0. So connect those points with a smooth and rounded curve. So that gives us our first wave of our sine graph. And so as you can see, to go all the way around our unit circle, we know that it takes 2 pi radians. So that's one wave, or it's all called one cycle, which is equal to the period of our function. Note that the maximum we have is up here at 1, the minimum's down here at -1. Recall that the midline is the distance between the maximum and the minimum value. So right here would be the midline of our graph. And you can take your maximum and your minimum values, add them together and divide by 2. So in this case, our midline, usually use D to stand for the midline, is equal to 1 plus -1 divided by 2, which is equal to 0. And then recall that the length of one complete repetition of the cycle is called the period of the graph. This is the horizontal distance before the graph repeats. And of course, that's one time around our unit circle, which is 2 pi. We can plug in any angle measures. So the domain is going to be -infinity to infinity. And the range, of course, is from the lowest, which is the minimum, -1, to the highest, which is 1 maximum. Now, for this graph, recall that we don't always want to graph all those values in between. So instead of graphing all those values in between, it helps to note the 5 key points in one period. So the key points are the maximums, the minimums, and the intercepts, or if you had a vertical shift, it'd be where the graph crosses your midline. And to get the key points, you divide the period of the function into 4 equal parts, and this will come in handy later when we are going to change the frequency of our graph. So that's why it's important to kind of think about it now. So right now, the period is 2 pi. So if we take 2 pi and divide it into 4 equal parts, because if you think about your unit circle, recall that that gives us our maximums and our minimums at those 4 equal parts, which is why we're dividing it by 4. So that gives me pi over 2. So on my graph, instead of having to always graph using pi over 6, pi over 4, pi over 3, we only need to graph our key points. So we would start at 0, 1 pi over 2, which is here, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi. So that is going to help us find our key points, and then you can even see on your graph. So this is my first key point, 2, 3, 4, and this completes the cycle. So that's why we have 5 key points on our graph. Now we can also talk about the midline on our graph. So the distance from the midline, the amplitude, the distance from the midline to the maximum is called the amplitude of the graph. So to find the amplitude, we can take the maximum minus the minimum divided by 2. So in this case, our amplitude would be equal to the maximum, which is 1 minus -1 divided by 2. So that would give us 2 over 2, which is just 1. So the amplitude of our parent graph is a value of 1. And so for this amplitude, again, you can count from the midline up or midline down. So this is actually the distance from here to here and here to here, and because it's a distance, that's why the amplitude is always positive, and you can see that that's a distance of 1. And of course, on our unit circle, we know that we have coterminal values. So because we have coterminal values, we can keep going on our unit circle and finding the different values. So like 13 pi over 6, I know is coterminal with pi over 6. So since it's coterminal, the sign of that would be 1/2. 9 pi over 4 is coterminal with pi over 4, so that would be root 2 over 2. 7 pi over 3 is coterminal with pi over 3, so that would be here at root 3 over 2, 5 pi over 2 would be up here. And again, we can just use our key points. So 5 pi over 2, the next key point value that we would have would be here at 3 pi. So that would be here. And then we could keep going. So the next key point would be at 7 pi over 2, so -1, and 4 pi. And of course, then we can connect our graph. And now you can see the second wavelength or cycle. So this would be the second. Normally when I'm graphing these, I like to graph 2 cycles, and usually I'll do a positive and a negative cycle, but this case we just did 2 positive ones, just to kind of get an idea. So I can do this same thing for our cosine graph, but recall that your cosine graph are these values on your unit circle that I just highlighted. So notice that the cosine graph starts with a y value of 1 and then goes down. So if we actually looked at the cosine graph, which we'll do again in just a second, you notice it starts up here at 1 and goes down. So our cosine graph would actually look something like this. But again, it's very similar to the sine graph. It just starts up, then goes down and back up to a maximum. And we'll look at that again in just a minute. So let's go ahead and do some practice. So before we start, recall that this is our general equation for sine and for cosine. And we know that that a value is equal to the amplitude. And of course, we always use the absolute value of a because if it's a negative value, we know that negative is actually a reflection across the x-axis. Recall if that a value is bigger than 1, it's a vertical stretch by a factor of the absolute value of a, and if it's in between 0 and 1, it's a vertical compression by a. So again, the absolute value of a is your amplitude, and we know that d is our midline of our graph, and again, we can use this formula right here. The key points is going to be the period divided by 4, so our parent graph period for now is always going to be 2 pi for sine and cosine. So when the frequency changes, which we'll talk about later, you'll need to know that it's going to be whatever that period is divided by 4. So we'll figure that out later. So looking at question number 2 here, we want to, it says the sine of x is the parent graph for all sine functions. We want to graph -3 sine of x plus 1 and 1/2 sine of x minus 2, and then state all of this information here. So for this graph, if we think about first just our sine graph, remember whenever you're graphing these, you want to really make sure that you're always on your x-axis writing down what your key values are equal to. So of course we know that our parent graph period is 2 pi, so 2 pi divided by 4 gives us intervals of pi over 2, so that's what I'm going to count by on my graph. So this would be 1 pi over 2, 2 pi over 2 is just pi, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, 11 pi over 2. Of course, always reduce your values. And then we can go backwards, negative pi over 2, negative pi, and negative 3 pi over 2. Now for this, again, make sure that you're always labeling each key value on your graph, because I'm going to look at that. And also you need to make sure you label your y-axis, because when we start doing our vertically stretching and compressing. So now that I have this, I can, of course, look at my sine graph, which we just did, and we know that it just repeats. So 5 pi over 2 is coterminal with pi over 2, so that's going to be up at here at 1. And then the next point we have is at pi, which is 0, -1, 0. And again, it's just going to keep repeating. I always like to draw the points because it helps me connect the curve. And of course we can go backwards, so -1, 0, 1, 0. So this is my parent graph for the sine of x, and recall that a is your amplitude. So in this case, y is equal to 1 times the sine of x and plus 0. So my amplitude is the absolute value of 1, which is just 1, and my midline is at 0. The period is 2 pi, and my key points, 2 pi divided by 4 is pi over 2. Now that I have this, I can see in my graph that I have 1, 2, 3, 4 wavelengths shown, so 4 different cycles. If we go ahead and start to graph our first function that we have, since we know our transformations, we can go ahead and use that to help us. So we have a reflection across the x-axis, a vertical stretch by 3, and up 1. And we know that this value in front is our a value, so we can say that the amplitude is the absolute value of -3, which is 3, and I know my midline is going to be moved up to 1. So you don't always have to graph all the transformations now that we've been doing them, so if you don't need to do that, you don't have to, but I'm just going to start off by graphing the transformations, and then later on we'll just look at the amplitude and midline to kind of help us. So here, if I think about the transformations, a reflection across the x-axis, this is on the x-axis, so that stays there. This moves down here, and I'm just going to do the first wavelength, and then I'll graph the rest of it. So that's a reflection across the x, and then vertically stretching it by 3 means we multiply our y values by 3, so this stays here at 0. This goes down here to -3, stays at 0, and then 1 times 3 is 3, and 0. So now we have vertically stretched our graph by 3, and then the next step would be to actually take this graph and move it up 1 unit. So if I just move that up 1, you can see it moved about right there. I'm going to erase the other graph. And now we can see our new shifted graph. So this is the 1 wavelength, and usually on my graphs I actually like to put the midline because I know my graph should oscillate back and forth between that midline, so it kind of helps me visualize what my graph should look like, and you guys should probably put that on your sheet too. So for this now I can kind of see my amplitude if I count 1, 2, 3 and 1, 2, 3, so that works out. I've moved my graph up 1, so now I know I've done my transformations. Now I know that my graph is just going to keep repeating itself. So at 5 pi over 2 I'm going to be back at -2, and then 3 pi would be 1, 4, 1, and so that would be my second wave. And then keep going. So -2, 1, 4, 1. That's my next wave, and of course I can go backwards on my graph. So we're always just repeating these values. So now I've graphed my transformations. So let's go ahead and go down to this table and look at some things. So for our parent graph, maximum we know is 1, minimum is -1, the amplitude is 1, and of course we could always use our formula that we have. So remember the amplitude is going to be your maximum minus your minimum. So 1 minus -1 divided by 2 gives us 1, so that's another way to find your amplitude. Your midline is going to be your maximum plus your minimum divided by 2, so that's where we get 0. Period's 2 pi for our parent graph always, so the key points would be pi over 2, and the range is -1 to 1. So then for our new graph that we just did, we can see that on our graph, the maximum's at 4, the minimum's at -2. So we have 4, -2. We said the amplitude was right here, so the absolute value of that is 3. Or we can, of course, use our maximum and our minimum. So maximum minus minimum, 4 minus -2 is 6, divided by 2 is 3. Our midline here now is right here at 1. And again, you can use your maximum minimum. So 4 plus -2 is 2, and 2 divided by 2 is 1. The period we're not changing for now, so 2 pi, the key points would be pi over 2, and now the range is from -2 to 3. So let's go ahead and take a look at the next graph that we have. So h of x equals 1/2 sine of x minus 2. So this is a vertical compression by 1/2, and we know we're going down 2, so my amplitude is 1/2. The midline would be now at -2. We still know our period's 2 pi and our key points are pi over 2. So we can use our transformations to help us graph this if we want. So 0 times 1/2 is 0. 1 times 1/2 is 1/2. 0, -1/2, and 0. So that would be my vertical compression. by half. And then we're moving our graph down 2, so down 1, 2 would be here, down 1, 2, down 2 is here, down 2, and down 2. So this would be my new graph. And of course I like to draw that midline on my graph because I know my graph has to oscillate back and forth, so this just kind of helps me do that. So the next one would be at a half, -2, -2.5, and again we're just kind of repeating. And of course we can go the opposite way in our graph. And so now I have my h of x graph, and so I can see my maximum is at -1.5, my minimum's at -2.5. So -1.5, -2.5, and then our amplitude, of course, we know is the a value, so 1/2. And then this is my midline at -2, or again, I can use those formulas, 2 pi, pi over 2, and now we have from -2.5, which is -5/2, to -1.5, which is -3/2. So notice that our domain of each graph is going to always be all real numbers. So -infinity to infinity. And the sine graph has symmetry with respect to the origin. And remember, origin symmetry means that this is an odd function. So for origin symmetry, remember if we have the point pi over 2, 1, then we have the negative of that. So -pi/2, -1, which is why it has origin symmetry. All right, so let's go ahead and look at the next graph that we have. Now we're looking at cosine. So for a cosine graph, this is our general equation right here. So again, A is the amplitude, D is going to be our midline. So for our graph, remember that the cosine of 0 is 1, the cosine of, and of course we need to write our key points on here. So this would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, and 11 pi over 2. And of course we want to do the negative direction, so -pi over 2, negative pi, and -3 pi over 2. So again, always make sure you label every key point on your axes for x and y. So then the sine, or cosine of pi over 2 is 0. The cosine of pi is -1, 0, and 1. So this makes our first wavelength for our cosine graph. So again, it looks like the sine graph, but we know it's cosine. And so then if I keep repeating my values, 5 pi over 2 is coterminal with pi over 2, so that would be here at this point at 0. 3 pi is going to be at -1, 0, 1. So again, we're just repeating 0, -1, 0, 1. And make your smooth and rounded curve. And we can go backwards. This would be 0, -1, 0, 1. So again, we just graphed 1, 2, 3, 4 wavelengths. And notice that one wavelength for cosine starts from a maximum to a maximum. And for this, for y equals the cosine of x, so our amplitude is 1 and our midline is 0. And our period is still 2 pi. And so our key points still go by intervals of pi over 2. The domain of our graphs are going to be, for all of them, -infinity to infinity. And notice that if I were to fold my graph in half on the y-axis, my graph would match up on the other side. Therefore, this is an even function, and it has y-axis symmetry. So if I look at my next equation here, for this one, we're looking at g of x. We know this is a reflection across the x, a vertical stretched by 4 and down 1. So my amplitude is the absolute value of -4, which is 4. And my midline is going to be at -1. My period is still going to be 2 pi. And my key points are still going by intervals of pi over 2, because we haven't changed that yet. So I'm going to graph this differently than I did the last one, just to kind of show you another way you can graph this. So sometimes what I like to do is I look at my midline, so I know that has to be at -1. So I know my graph is going to be oscillating back and forth between this. And we know that since the amplitude is 4, it should go up and down 4. So on my graph, I know that because of the reflection, instead of being here at 1, it would actually be down here at -1, but then we're stretching that by 4, so I should count down 1, 2, 3, 4. And then here, this would be staying there, but then of course we're moving it down 1, and so that would be here. This value at -1, if we reflect across the x-axis, would be at 1, and 1 times 4 is going to give me 4. But again, we're moving that down 1, so that's going to be at 3 now. And you can count 1, 2, 3, 4 here. So this would be here, and this value would be down here. Or if it helps, you can actually make a table. So if I make a table, these are your x values. So you can do all your key points: 0, pi over 2, 3 pi over 2, pi, 3 pi over 2, 2 pi. So then for g of x, the cosine of 0 is 1. 1 times -4 is -4. And -4 minus 1 is where we got the -5 from. If we plug in pi over 2, the cosine of pi over 2 we know is 0. 0 times -4 is 0 minus 1. The cosine of pi is -1, so -1 times -4 would give me +4, and 4 minus 1 is where the 3 comes from. The cosine of 3 pi over 2, when I plug that in for x, we would get 0, and 0 times -4 is -4 minus 1, and then the cosine of pi over 2 again is 1, so 1 times -4 is -4 minus 1 is -5. So if it helps you to make a table, you can also do that. Again, it's just kind of whatever helps you to graph these now. So then the next part, I would just keep repeating those values. So we start at -5, so we have -1, 3, -1, 5. So -1, 3, -1, -5. So that's the second wave. And it would still repeat. And the next wave. And of course we can go backwards on our table. This would be the negative cycle. So now I have my new graph, and I can see the maximum's at 3, the minimum is at -5. So let's go ahead and fill out some of this table down here. So let's start with the parent graph. Maximum was 1, minimum -1, so we know the amplitude is 1, midline 0, 2 pi, key points were at pi over 2, because remember you take the period and divide it by 4, and the range is from -1 to 1. So now for our new graph, the maximum was now at 3. The minimum was at -5. So the amplitude is, again, the absolute value of -4, which is 4. Or you can take your maximum and subtract it from your minimum divided by 2. So 3 minus -5 is 8 divided by 2 is where we get the 4. The midline is this value right here, is -1. And again, you could take the maximum plus the minimum divided by 2. Period's 2 pi. Pi over 2 are the intervals for the key points, and now we have from -5 to 3 for my range. So the last graph that we're going to look at is h of. So for h of x, I can see my amplitude is equal to 1/2. My midline is going to be at 2. And so for my graph, I'm going to first graph my midline, which is at 2. So now that I have my midline, I can go ahead and start to think about graphing. Now, again, you can make all the transformations you want, or you can make a table, or you can just kind of do them in your head. It's up to you now. So I know that the cosine of 0 is 1. 1 times 1/2 is 1/2, plus 2 gives me now 2.5. So that means now I've moved up to here, 2.5. Then at pi over 2, the cosine of pi over 2 is 0. 0 times 1/2 would be 0, plus 2 is just 2. So now this point is here at 2. At pi, the cosine of pi is -1. So -1 times 1/2 is -1/2, plus 2 would be 1.5. And then the cosine of 3 pi over 2 is 0. And so that's going to be the same as this value here, so 2. And the cosine of 2 pi is 1, which is the same as 0. So that's going to give me 2.5. So on my graph, pi over 2, I have 1.5. 3 pi over 2, 2, and 2 pi, 2.5. So that is my wavelength for this graph, and of course that's going to keep repeating. So 2, 1.5, 2, 2.5, 2, 1.5, 2, 2.5. So of course I can keep going on my graph. And I can go the negative direction as well. So now I've graphed g of x, and again, you can use your transformations, you can use a table, whatever helps you to graph this. And I can even check my work because from my midline up, I have 1/2. From my midline down, I also have 1/2, so it looks like it's right. So you can see your maximum's at 2.5, your minimum is at 1.5, so let's go ahead and add that to our table. So 2.5, 1.5, so my amplitude is 1/2. And my midline is at 2, the period's still 2 pi, pi over 2, and now my interval for my range would be from 1.5 to 2.5. The next thing that I want to look at is writing the equations of the graph. So if you want to write the equations of the graph, the first thing that you would do is look at your maximum and your minimum values. So my maximum value is at 2, my minimum is at 0, so my amplitude, remember, is the maximum minus the minimum divided by 2. So in this case, I get 2 minus 0 over 2, which is equal to 1. So then the midline is the maximum plus the minimum divided by 2. So in this case, 2 plus 0 divided by 2 is also going to give me 1. So on my graph, I like to draw the midline in. That helps me visualize what the graph is going to look like. So I can count up 1 and down 1 from the midline for my amplitude, so that checks out. And for this, I need to figure out now, is this a sine or cosine graph? So if on your y-axis it crosses on your midline, you know it's going to be a sine graph. If not, then it's cosine. So in this case, it crosses here on midline on the y-axis, so I know it's going to be sine. So if I count 1, 2, 3, 4, 5 points, I can see that this is my one wavelength, which is 2 pi. So that period didn't change, which we haven't done yet. So I know I have the general equation, y equals a times the sine of x plus d. So we found our amplitude at our midline, so I just have to plug those values in. So y is equal to 1 times the sine of x plus 1. And of course, we don't really need to write that amplitude 1 there, but if you like to, you can. So I'm going to go to my next graph and do the same thing on the next page. So same thing, we want to write the equation for this graph. So I want to figure out what my maximum value is. So my maximum looks like it's here at 1. The minimum is here at -3. So remember that to find your amplitude, it's going to be your maximum minus your minimum divided by 2. So that gives me 4 over 2, which is 2. Then my midline is your maximum plus your minimum divided by 2, because it's the average. So that gives me -2 over 2, which is -1. So we're going to have to graph that first. So I can see this is my midline. I can count up 1, 2, and down 1, 2, so I know my amplitude's correct. Now for this graph, if I look at my y-axis, notice that my graph is not starting on my midline, it's right here. So that tells me this is a cosine graph, so I count 1, 2, 3, 4, 5 key points, because remember your key points are your maximums, your minimums, and where it crosses your midline. And I can see that the one wavelength goes from 0 to 2 pi, so my period still stayed 2 pi. And for this, now I need to write the equation. So y is equal to a times the cosine of x plus d. But you have to be careful because remember, the cosine graph normally starts up at a positive value of 1 and then goes down. But this one is starting down here, which means we had a reflection across the x-axis. So in this case, I should have y is equal to -2 times the cosine of x minus 1. So this would be my equation for the graph. So now we're going to look at evaluating some of these functions that we have for sine and cosine. So it says for this question here, find all the exact t values for which the given statement is true. So for this, I have the sine of t is equal to 1. So you can think about your graph or you can think about the unit circle. If I think about the unit circle, remember that we have the coordinate order pairs cosine theta comma sine theta. So it's our y coordinate. So where's our y coordinate? 1 on our unit circle right here at pi over 2. And notice that it only hits at one place on my unit circle within one time around our circle. Or we can think about the actual graph for sine. So remember, it starts at 0 and looks like this. And you can even see on your graph it only hits at one place on one wavelength. So that means we only have one solution. So our solution would be t values equal to pi over 2. But don't forget, we can also go around our circle um, multiple times. So we have coterminal answers as well. So if we go with our coterminal answers, that means we're going to add 2 pi, because that's how we find coterminal answers, times n, where n is an integer, because we can also go the clockwise direction, which would give us negative angle measurements. So this would be the solution for all of t values for which the sine of t is equal to 1. And even just to check, like if I were to plug 1 in here, so I get pi over 2 plus 2 pi, so get a common denominator. So that makes this pi over 2 plus 4 pi over 2, so that's 5 pi over 2. So we know 5 pi over 2 also gives us a sine value of 1. If I now look at my cosine of t equals negative 1, so now we're looking at the x-coordinate on our circle, which is right here at pi. And if we think about our cosine graph, remember it starts at 1, 0, negative 1, 0, 1. And you can see it only hits in one place on our one wavelength, or one place on our unit circle. So we have one solution, which is equal to pi plus all the coterminal answers, so 2 pi times n. If I now look at root 2 over 2, so on my circle, remember that cosine is positive in quadrant 1 and quadrant 4, because that's where your x values are positive. So root 2 over 2 hits here, and it hits here, so at pi over 4 and at 7 pi over 4. So now in one wavelength, we actually have two solutions that we have. And if you look at your graph, the same thing. So if we're looking at root 2 over 2, that would hit somewhere here and here in our graph, so two solutions. So now our t value is equal to pi over 4 plus all the coterminal answers, 2 pi n, and t is equal to 7 pi over 4 plus 2 pi n. So now we have two solutions. So if I look at the sine equation, sine of t is equal to negative 1/2. So I have to think about where's the sign negative. So I get negative values in quadrant 3 and in quadrant 4. So negative 1/2 would be here and here on my unit circle. So I have to think about those radian measures. So 7 pi over 6 and 11 pi over 6. So now I can write my solutions, and I can also think about my graph. I had negative 1/2 here and here. So t is equal to 7 pi over 6 plus 2 pi n, and t is equal to 11 pi over 6 plus 2 pi n. So that's why it's really important to make sure that you know your unit circle, because now we're going to actually solve these equations where you have to figure out what is that angle measurement where we have the sine of t equals to negative 1/2, or the cosine of t is equal to root 2 over 2. So we'll go ahead and do some more practice of this in class tomorrow.